section on inequalities. So we've been solving them, whether they're just one-step, two-step, compound, absolute value. Well, now let's graph them. We want to look like what it looks like on a graph. So steps for graphing linear inequalities. Well, if it's a linear inequality, it's going to make a line. And that's all we've been working with in algebra is our linear equations. So first things first, when I see linear, I'm thinking slope-intercept form. Okay, so we're going to get our equations, our inequalities in this case, in slope-intercept form, and we're going to graph them. There's a couple different rules, though. First thing I need to do is graph the line. Graph the boundary line is what we call it. Well, there's two ways I can graph this. I can either have a solid or a dashed line. Well, every single time we graphed it before, it was a solid line, and it was because it had an equal sign for slope-intercept form. Now I'm going to have an inequality sign. So if it still has the equals with it, so like less than or equal to or greater than or equal to, it's going to still be a solid line. If it doesn't have the equal to with it, less than or greater than, now it's going to be a dashed line. And I'll explain why that is in just a little bit. Okay, so solid, if the equal to is still there, it's going to be dashed if not. Well, after you get it graphed, you're going to use a test point to determine where you shade your graph. Okay, we're actually going to shade part of the graph when graphing inequalities. And you cannot test a point that's on the line, because that does not help you. And then after you test the point, you shade the half plane that contains the solution. Well, if the point works, you shade that side. If the point does not work, you shade the other side. And let's take a look. It's kind of confusing just looking at it in words. If we do an example, I bet it'll make sense here. So here we go. I have an inequality. 2y minus 4x is greater than 6. Well, like we said, if we're going to graph it, let's get it in slope-intercept form. And the only difference is there's just not going to be an equal sign anymore. So let's get our y by itself. So we've got to bring our negative 4x to the other side. So the inverse of subtracting 4x is adding 4x. Whatever I do to one side, I do to the other. So now I'm left with 2y is greater than, I can't combine those. We always put the x first, right? If I look at my slope-intercept form, the x term comes first. So 4x plus 6. It's a positive 6, so plus 6. And then to get y by itself, we divide by 2. Divide by 2. So y is greater than, then we split this up. So 4x divided by 2 is going to give me 2x. And then positive 6 divided by 2 is going to give me a positive 3. So that's what I'm graphing. I just imagine it that it's in slope-intercept form, like y equals mx plus b. So really y equals 2x plus 3. So if I look, I have a y-intercept of 3, and I have a slope of 2 over 1. Okay, so I don't actually have to write this out, but just imagine, right, that the equal sign's there instead. So it's in slope-intercept form. It's just a greater than instead of an equal sign. So I go ahead, I graph my y-intercept at 3, and I go up 2, right 1. I can go left 2, down 1 as well, or down 2, left 1 as well. Okay, and before I graph my line, I can figure out, is it going to be a solid line or a dashed line? Well, it has to be a solid or a dashed line, and I'll tell you why. Because none of the points on the line work. Let me graph my line here first. If I think about this, my original equation was 2y minus 4x is greater than 6, right? Because if I picked the one point I know is on the line, for example, 0, 3 here. If I plugged in 0, 3 into my equation, it would not work. So 2 times 3 is 6, minus 0. Is 6 greater than 6? No, it is not. So I cannot have a solid line. It has to be dashed because of the greater than. There's no equal to. That's why it's dashed. So you don't actually have to do that, but I was just explaining why it's dashed. So just know, no equal to, so that means it's dashed. Next part, to figure out where we shade, I pick a test point. And I'm going to pick a test point that's not on the line. The easiest one to pick, as long as it's not on the line, is right here at the origin at 0, 0. So I'm going going to go ahead and plug that in. So 0 for y, 0 for x, and I got 0 is greater than, well, 0 plus 3 is 3. Is 0 greater than 3? No, this does not work. That does not make sense. 0 is not greater than 3. So what that means is I shade the other side of the line. Since 0, 0 was over here and it didn't work, that means none of the points on that side work. But all of them on the other side work. So I shade this entire side of this line. So what that means is if I pick any point over there, it doesn't matter which point. For example, I could pick 0, 7. I could pick 0, 7. And if I plug that into my equation here, if I plugged in 0, 7 into this equation, I'm going to bring this down here, it should work. So 7 is greater than 2 times 0 plus 3. Is 7 greater than 3? Yes. So every point I pick on the shaded side should work. Let's try another example. I know I did a lot of explaining there. This time I won't explain as much. I'm just going to do the problem. So same thing. We want to get y by itself. We want to get it in slope-intercept form. I'm going to go ahead and subtract x from both sides. And I'm left with 4y is greater than or equal to, well, let's put my x first. So negative x and a positive 2. I always keep that silence in front. Then to get y by itself, we divide by 4. Remember, if I would divide by a negative on both sides, I would need to flip the sign. But in this case, it's a positive, so I'm okay. So that cancels. I'm left with y is greater than or equal to, well, negative x over 4. But what we want to do is pull the x out and leave a 1 up top. So I'm going to write it as negative 1/4 x. So then I have a slope to work with. And 2 over 4 simplifies into 1/2. I like keeping fractions instead of decimals, so I'm more accurate all the time. So now let's go ahead. I have a y-intercept of 1/2. So I go up. And if I wanted to, I could just count by halves here. I could say this is 1, this is 2, this is 3, this is 4. That might make this, whoop, that might make this a little cleaner. So 1, 2, 3, 4. So now I'm going up 1/2 for my y-intercept. And my rise over my run, so that means I got negative 1/4. So I either got to put the negative to the top or the bottom. So I can either go down 1, right 4, or I can go up 1, left 4. So I'm going to go down 1. So down 1. So down 1, right 4. So 1, 1, 2, 3, 4. So I'm over here. Same thing, I can go up 1 and left 4. Up 1, left 4. 1, 2, 3, 4. And if that's difficult, scaling your graph the way I did, just leave it as count by ones. And now I'm going to draw my line. Well, do I need a solid or dashed line? I have the equal to now. So I need a solid line, because points on the line will work. And then we pick a test point. So if 0, 0 is not on the line, I'm going to pick 0, 0. So let's pick 0, 0. I'm testing 0, 0 here. So 0 is greater than or equal to negative 1/4 times 0 plus 1/2. Well, is 0 greater than or equal to 1/2? No, it is not. So that means I shade the opposite side. So I'm going to shade the other side since it did not work. There we go. I'm done. Okay, I can do it when there's just one variable, when it's just x or y, and we can still graph that. So let's go ahead, let's get x by itself here. I'm going to add 3 to both sides. And then I'm going to divide by 4. So we get x is greater than or equal to 5. Well, remember how to graph that? If it was like x equals 5, I just go to 5 on the x-axis, and I put in a vertical line. Well, in this case, it needs to be solid because I have greater than or equal to. The equal to makes it solid. And still the same thing. I pick a test point. So I'm going to pick 0, 0, and I'm going to test it. Well, I don't need to plug in a y. There's just an x. So is 0 greater than or equal to 5? Nope, doesn't work, so I shade the other side. That should make sense, right? Numbers greater than or equal to 5. Same thing with the y over here. Subtract 3 from both sides, and I'm left with 2y is less than 4. Divide by 2, and y is less than 2. So now I go to 2 on the y-axis, and I draw in a horizontal line. Oh, I screwed up. It should be dashed, right? So don't work too fast. Always think through. The dash are solid. Dash because there's no equal to. Then we pick a test point. I usually pick 0, 0. If it's not on the line, and it's not, so I pick 0, 0. Is 0 less than 2? Yes, it is. So now I shade on the side of the point I tested. There we go. Okay, so just follow those steps. Figure out if it's solid or dashed after you get in slope intercept form. Pick a test point, usually 0, 0 if it's not on the line. And then if it works, shade that side. If it doesn't, shade the other side.